Okay, hi guys. So welcome back to day two, part 4, which is going to be the last part of this class for day two. So after this, we're moving to day three. If you haven't watched part three, there's going to be a link here, so you should go check it out. So in part three, we talked last about exec function, exec ve, right, which helps us to replace a particular um, execution, a particular process, right, with a particular execution, right, which truncates the remaining part of the first execution, right, whenever we call that function. Okay, now we are going into creating processes. So earlier we talked about PID, which is process ID, right? So each process would have a unique ID, right, for that process. So if you see that when we execute two different commands in that video, right, probably I'm going to put the link to that video here. So when we execute two different commands, right, you see that each command has its own process ID, right, identification for that process, right? Okay, so basically in order to create duplicate process ID, and what would creating duplicate process ID help us with? One, if we create duplicate process IDs, like, right, so if we have this process ID, right, and process ID 2, right, it means this one we can use it to execute one command. My light is off. And this other one we can use it to execute another command. So command 1, so we can use one to execute this and this one to execute command 2, right? So this is basically what this guy does, right? So we want to create that process. Okay, so the fork, the system called fork, is a system call as well. It will help us to create a new child process, because the new one we call it child and the old one we call it father or parent, right? So almost identical to the parent. So a new process will be created when we use this fork. So we'll man fork and we'll check. Okay, we'll man fork, we'll check, and we'll see. So a new process will be created. So we'll have two process, and then once fork successfully returned, two processes continue to run the same program but with different stack data and heaps. Okay, so basically we just have two process undergoing this thing. Like we have two we'll have two process running the same commands that we've written in the code, right? So in the exec one, we are using one to replace the other one, but here we are duplicating it. We want it to run twice with different process IDs. Okay, so the new one created by fork is called the child and the old one is the parent or father, right? So that's basically it. So let us man fork and let's go through this example, and we'll go through the next example, and then we'll also do our own, and then that will end fork for now. So let us man fork. Okay, so as you can see, um, these are the synopsis. We have the include system types.h unistd because it's a system call, and then the return is also saved in a PID underscore t, just like a um, process ID. So the return could be a process ID, it could be an integer, it could be a negative number. Okay, so it depends on whatever it is. So fork creates a new process by duplicating the calling process. So there's a process running that program. Okay, so when we have this program, there's a process running it before you call fork. So by the time you call fork, it will duplicate that process. Okay, so that's what that place is telling us. And then the calling process is referred to as the parent process. The child process and the parent process run in separate memory. So these are one of the differences. They just run in different memory, but they are still running the same program. And at the same time of fork, both memory spaces have the same content, you see. So memory writes, file mapping and unmapping performed by one of the process do not affect the other. So the child process is an exact duplicate of the parent process except for the following points. So these are what makes the child process different from the parent, right? The child has its own unique process ID, and the PID does not match the ID of the existing process group, right? And then the child parent process ID is the same as the parent process ID. So this one is just trying to say the normal parent ID, that's the normal PID of this guy, is the same thing as the normal parent ID of this work we are doing, okay, of this execution, right? So and so on. The child set of pending signal is initially empty. The child does not inherit semaphore adjustment from its parents. So all these ones are just more attributes that differentiate them. So let's see the return. Okay, let me see, is there anything like return? Where's the return? Page up, page down. Okay, maybe I should man 2. Let me see, is it just man? Yeah, man 2. Let me man 2 fork. So did I did man 3, man 2? Okay, because this one didn't give us much more data that we need. Okay, let's see, page down, page down, page down. Okay, is that an example? No, this is not what I'm. Okay, yeah, I've seen it. So on success, the PID of the child process, that's the process ID of the child process, is returned in the parent, right? It's going to be returned in the parent. Okay, as you can see, the PID is returned in the parent, and then 0 is returned in the child. Okay, so we have two different PIDs, right? We have two different PIDs now, right? Process ID. Let me remove this one. So this one is after you say maybe this guy, one process ID 1852 is the one executing the okay, I think is the one executing this program. So this one will still be 1. Okay, so 1852 is the one executing this guy. So by the time you call fork, okay, so fork would duplicate it, and then this one will become the child. Okay, this one will become the child, and then this one is still the parent. Okay, and then this one is still the parent. So this process ID continue to execute the code, and this one starts its own execution from where this guy starts. Okay, and then you get the same output, right? Okay, so by the time you do this fork, if you want to know which one is the parent ID, which one is the child, okay, so to this the fork will return, this one is return type would be, okay, if it will return 0 to the child. Okay, so that's how you know that it is the child own. Okay, to the child, right? And then the fork will return positive value, which is the PID of the child. Okay, which is 1853. Remember that PID are positive number for the parent. So once you see that its return value is the PI is a positive number, because we can't know what number it's going to be. We just know that it's positive, so it has to be greater than 0. Okay, and you know that it is for the parent. But if it is not successful, okay, if it is not successful, then fork will return a negative number, which is -1 for unsuccessful. Okay, and that is that. So basically this is what happens, right? Okay, so sorry. Okay, so ignore these guys. This one is the return value, right? So this guy is coming. By the time, okay, no, by the time you use fork, I think I'm supposed to do, by the time you use fork, it would print out this thing. And for you to identify this, you know that the fork will return -1 when it's unsuccessful, returns positive number to the parent, and then telling you that that's the parent, and then 0 for the child. Okay, so that's how you know that. So let's go back to the concept, or let me cd into our shell. Okay, good. So the next thing we're going to do is, let's us copy this guy and explain this guy, right? So we have this, and it is called fork.c. So vi fork.c, and then we'll paste it. But before I exit it, okay, let me just exit and go here. So basically what will happen is that we have this PID underscore t to save our PIDs, right? And we just gave it a name. So this one is simple, right? So we just want to run a normal program. We are not doing anything, okay? So we said it should just print before fork. Simple. It's going to print before fork, as you can see, right? Good. So the next thing we said is, we say fork this guy, right? We call our fork function, but we say that we now save whatever is going to return. We save it inside PID. Okay, and remember that return type of fork is in PID underscore t, right? Because it could be a PID, it could be a 0, it could be -1. So that's why we saved it here, right? We saved just the return type here. Okay, so we are not using the return type, we just fork it. So by this time, we have two things running the program now. Okay, so before fork will be printed just once. Okay, and then we have two things running now. So anything we want to print out now will be in duplicates. Okay, parents will do one, child will do one. So if our return guy, which is PID, is -1, it should print error. If not, yeah, let's see. So now if not, it should print after fork. So the parent will print after fork, the new child that has been created will print after fork, right? So we have after fork, and then we have after fork, right? So after that, we had our my PID, and then we want to get the PID. So when we get the PID here, we are getting two PIDs: the PID of the father, which is the parent, and PID of the child. Okay, so we are getting two PIDs here. Okay, so we are now saying it should print out the PIDs. So my PID is, okay, so my PID is, so with this we are going to have the PID of the parents and the PID of the child. So as you can see, after work my PID is this, after work my PID is this. So we have 4819, 4820. So this 19 is the parent, this 20 is the child, and the next program would help us know which one is parent and which one is child. But let us execute it and see if it's going to give us the same thing. Okay, so no such file or directory, no input files. What's going on? What's going on? Compilation terminated. Why is it not compiling? Cat forgot. Didn't I put the other files? Oh, sorry. Yeah, they're there. Or probably I'm not compiling it right. Though they didn't put the compilation stuff there. Should we compile with a flag? Let's see. Fork.c. Okay, so gcc fork.c output as fork. Okay, maybe I misspelled it. Let me see. What did I press before? Look at my fork. I misspelled it. All right. I was wondering what happened. All right. So look at they made a typo here because this guy is not supposed to be here, and they said note there is no typo in the above example, but there is a typo because look at what we run. We are not supposed to have that. Anyway, so we have our before just once, and then after fork my PID is this, after fork my PID is this. So we had two guys now executing it after we used that fork, right? So that's basically what that is. So we want to know which one is the parent, the existing one, and which one is the new one that fork created. Okay, so the next example would help us out with that. Okay, this one says there is no typo in the above example. Using the return value of fork, right, it is possible to know if the current process is the father or the child through the return value, like I said. So fork will return 0 to the child and the PID of the child to the father. So to the father is going to return PID of the child. Okay, so let us copy this guy and explain this guy and see what it does. Okay, so this one is a very long guy. So copy vi, what's this guy called? Fork as well. Let me call it fork1.c. I don't want to override that one. Okay, so I can gcc compile it fork1.c. I'm still supposed to explain it, so let's call it fork1. Okay, okay, so let's explain and see why all these things is being gotten, right? So we have it, we want to know which one is for the father, which one is for the child, right? So we have this guy declared as usual, right? Then we declared fork, and from here we have our child and father, right? So the return value of fork, we gave it to child PID, right? So this guy is holding the return value. Okay, so we first check if the return value is -1, right? It should print this error. So once it is not, it's going to go to the next one. Remember, it is two process that is running this guy. So you see it as two people now. You've created two people, and then the two of them are both running the same errand, right? Okay, so it's two process running the same errand. So we then get the PID, which will be 2 now. We'll be getting two PIDs here, right? We want to get two PIDs, and then we want to get PID, but PID for father will be gotten, right? And then PID for child also will be gotten, right? So that's that. So we have PID saved in my PID. So it will then print my PID is the value. Okay, so if you look here, we have the first one. where is it? My PID is 2689 and then my PID is 2690. So one is printing this, one is printing this. So which one is the father, which one is the child? As you can see, 89 is the father, 90 is the child, but let us see how they figured out, right? So what next is we're going to check true and see. So if we have this guy, where is it? Where are we? Okay, so we gave a condition. We can use this return type that, okay, if this return type is 0, right, it should print no and then the value, right? So that is to tell us that, okay, that particular one, that particular value is the child, right? So if you go here and you can see it prints no and then the child. Look at it here. So my PID %u is here, right, to print it out, right? That is why it is printing it first. Okay, so the top one, so if you notice, the parent is the one executing first, right? So look at the parent now. So the parent, else you should print, it means that it is a positive number. Okay, so we now say %u, I am your father. So the father did what? My PID, which is the PID of the father, will be printed first, and then whatever the return type of this guy is, it should be here. And remember that it will return the child PID, right, if it is to the father, right? So this one will have both the father and the child's PID. So if we check, we'll have father and then child PID and father. I hope this explains it. Okay, so that would be that. So there's one more thing I would want to do, okay, to make it to is something they didn't include, right? So what if we call fork so many times? Okay, so I'm just going to write a simple program that would help us use fork effectively. All right, so let's give it vi my fork.c. So I'm going to include my stdio.h, and then I'm going to include my uni std.h. Okay, so we'll have our int name and then we'll have our void. Okay, so the next thing we're going to have is let's just say we want to print f, right, and then at the end return 0. Good. So we want to print okay, %u, this is my PID. Okay, and then what do we do? Get PID. Okay, are we supposed to put semicolon here? I'm not sure we're supposed to do that. Okay, so basically let's run this and see. So what I wanted to do is just to get PID of this process and then print it out, right? I don't know if this explain this. I didn't use variables. I want to get it directly. I want to see if it's going to print it out. So let's see. GCC. So my fork.c and the output as my fork. Alright, so it's run my fork. This is my PID, right? So let me just add a new line. So if I run it one more time, it's going to have 9, right? So it's working. So let me just add a new line to it, and sorry, I want to open the executable. Let's see. Okay, so at the end you should have a new line, sorry, a new line, right? So that will be that. Okay, good. So we have this done. So if I GCC back and we compile, we have my fork, right? Good. This is my bed. So let us run this guy. I think I would have someone is coming, so I have to be fast before the person gets here to interrupt us. Okay, so the next thing is I'm going to create my fork here. Fork this and this. Okay, so we are having to process now. So by the time I execute compile and execute this guy, okay, so we have the PID now. So this is my PID, this is my PID. So one, we've created two. So one is acting as the child and the other is acting as the parent. Okay, so the next thing we're going to do is we are going to sorry, I had people coming in. I told you, so I've told them I'm busy. All right, so let's continue. So let's bi my fork. Okay, dot c. So as you can see, we have the two PIDs created. Okay, so what happens when we call three PIDs? Fork like this, and fork. How many times do you think this guy will print, with knowing that PID would create multiple PIDs, right? So we have three PIDs. If you know, drop the comments on the comment section. I'll be waiting for you for 30 seconds. Are you done? Okay, let's see if you're right. Okay, so let us compile and let us run my fork, right, my fork. Good. So look at it, we have it's printing it 1 2 3, right, 4 5 6 7 8. Okay, so let's see, why is it printing 8 times? Is that what you wrote? I'm very sure probably some people wrote 4. I don't know. So let me explain why it's printing that much. Okay, so basically what we did is, okay, so we add our fork 3 times. So when we create our first fork, right, remember that it's going to create one parent and one child. Okay, good. So by the time we create the second fork, this parent would have one parent, one child, right, and this child, right, will have one parent and one child. Okay, by the time we call the next fork, which is the second fork, this parent, right, would have one parent, one child. This guy over here will have what? One parent, one child, right? This one too will have one parent, one child, one parent, one child. So let's just copy this and then, okay, so let me reduce the screen, or let me increase it to right button. So we've called fork, wait, 1 2 3, right, 3 times. So we have 1 2 3 4 5 6 7 8. Okay, so this is why we would have it. So we have this guy executing the remaining part, this guy executing the remaining part, this guy executing. So I have 8 lines of code. So basically that's it. So that's basically what I want to do on fork. So you can still try and read extensively on what we've learned so far. So far, this is the end of day 2. So far we've learned the PID, right? So we've learned the PID, yes, that's the process ID. Process ID. We've done PPID, that's the parent process ID, right? We've learned that. We've learned argument to main, right? Argc and argv, which is argument to main, right? We've done that. We talked little about is it exec next or okay, I don't exec ve, right? We talked about exec ve. We talked about fork. We talked about string token that separates, right? So we've talked about 1 2 3 4 5 6, and which other concept have we talked about that I didn't mention? Let's go from home. PID, PPID, we've talked about arguments, we've talked about exec v, we've talked about fork. Where is the string tokenization? PPID, where is it? Yeah, get line. We've talked about get line and string token. Yes, get line, string token. Yes. So I need you to do a revision. Get line and what again? What did we saw just now? Get line and sorry, I got distracted. I saw one that we didn't include just now. Get line and we've said string tokenization. Get line. Okay, I think that's that. Okay, so 1 2 3 4 5 6 7. So we've learned these 7 things, and yeah, so if there's any other one we've learned I didn't include, you can let me know in the comment section. So try and read on this, and then we'll go to the next one, which would be what? For day 3 we're going to go to the next. So we know how to create different processes, right? So next we are going to wait. Okay, so next we're going to go to wait for day 3. All right, see you in the next video. Bye.